Hello, welcome back to trigonometry. We are getting ready to embark on a unit that I find to be a blast, and that is the unit with identities. Today we're going to talk a little bit about fundamental identities, but in the near future, like next podcast, we're going to talk about verifying trig identities, and it's so much fun. To me, it's like solving a puzzle. Trying to make those two sides fit. Making the pieces fit. So we're going to end up going through and looking at a bunch of identities and how to verify and how to work with them, how to use them, etc. And that's what this whole unit's going to be about. And then make sure you check the course resources because there's some identity sheets that have been posted. One of them has a lot of identities listed, and then another doesn't have so many. Look for the sheet that has your author's textbook's name on it, and that'll tell you which sheet to use. And that's the sheet that you'll be allowed to use on your test and so forth. And then check the news items when the test is being mailed out about what sheet you're going to be provided and so forth. But anyways, I'm jumping ahead. For now, let's just introduce some identities and start working with them, having some fun with them, and go from there. Now, some of these fundamental identities you guys have already seen. You've seen them a while back, like 2 units ago or so, like beginning of the course, kind of 2 units ago. So they're nothing new. You might be sitting here going, yawn, I've seen these, what is she doing this again for? But we need to review real quick and make sure you've got them on your tool belt here. You guys already know that cotangent theta is 1 over tangent theta. So that's old news. But that is considered to be an identity. An identity is basically an equation or a formula. The equal sign is true. And then once you know that this equal sign is true, once you've proven that, then you can use that fact to do all kinds of problem solving. You guys know that secant theta equals 1 over cosine theta. That's another identity. You guys know that cosecant theta is 1 over sine theta. That's another fundamental identity. So these are old news. Some others that are old news. Okay, yeah, these are considered to be the reciprocal identities here, because they're found by doing reciprocals of trig functions there. These are reciprocal identities. Another group that's old news for you guys is the quotient identities. You know that tan theta equals sine theta over cosine theta. We've learned that in the past. You also know that cotangent theta is the reciprocal of that, so it's cosine theta over sine theta. So we call that quotient identities. Okay, and then the Pythagorean identities, you've seen them before too, but you're going to find that they get used a lot. Sine squared theta plus cosine squared theta equals 1. And then we learned how you could divide both sides by sine squared theta and end up with 1 plus cotangent squared theta equals cosecant squared theta. You've also learned how you could divide both sides by cosine squared theta and end up with tangent squared theta plus 1 equals secant squared theta. But these are Pythagorean identities. We learned those, and you can always manipulate those some, like sine squared theta equals 1 minus cosine squared theta, or use a little algebra and solve for one to get another identity basically. And you can use those. And then to round off this list, let me show you 2, 4, 6 more, or how to get 6 more identities. But you've been using these, but you want to know these solid because you're going to be using them a lot with the next several lessons with identities. And these kinds of things will not be provided for you on a test, so you need to know them on a test. But some of the others we want to talk about are the negative angle identities. Oops. Let me undo that. I don't want that blue mark up there. All right, we're going to look at the negative angle identities. And with those, we can look at an axis system and start getting ideas about what's happening with those. Draw XY axes, and then let's draw a circle. Let's just draw points. Let's just talk about points. Let's say you have a point out here. We'll call it XY. Alright, and I'll draw a little segment from XY to the origin here. Okay. So, like if you have that point, let's say that point, let's say that we have this angle theta going this way. And really XY can be anywhere on this grid, but in order to demonstrate this, it's good to just stick XY somewhere out there. So something like this, you've got, this is a distance R, and then going down this way, you've got a distance Y, and then going that way, you've got negative X. Well, then if you do negative theta and go the opposite direction, go this way, do a negative theta, then some interesting stuff starts going on there. Okay, so negative theta going that way. Then your y for that one is a negative y. But you start looking at stuff. Your sine of your theta here, for this particular one, sine is opposite over hypotenuse, will be y over r. But your sine of your negative theta ends up being negative y over r. We'll label that r also. So essentially, your sine of negative theta equals negative sine of theta. You see that? Your sine of negative theta here equals negative y over r, which is the opposite of what sine theta was, y over r. So if you take sine theta and do its opposite, that equals sine of negative theta. It's the same, it comes out the same. So that's one of your negative identities. Then the same thing's going to apply for its reciprocal, cosecant of negative theta. If you have sine of negative theta equals negative sine theta, then looking at the reciprocal function, cosecant negative theta is going to equal negative cosecant theta. So that's two of your negative angle identities. So sometimes that can be useful. All right. Same figure. Let's look at cosine. Cosine theta in this one is, in this case, we got negative x over r. Cosine negative theta is the same, negative x over r, from this figure. So you can say that cosine negative theta comes out the same as cosine theta. And that's going to be true for its reciprocal, secant. Secant negative theta is going to equal secant theta. So that's two more negative angle identities. And then we know that tangent of theta is sine of theta over cosine theta. So tangent of negative theta is sine of negative theta over cosine negative theta. Which equals negative sine theta over cosine theta, using our identities we already have, or negative sine theta over cosine theta. So the tangent of negative theta is the same thing as negative tan theta. But that also, if you think about, okay, then let me quickly mention reciprocal. Cotangent negative theta is going to be negative cotangent theta. But we kind of already knew that too because of our graphing. Remember when we graphed sine went like this. It had that origin symmetry. If you started rotating around the origin, had that origin symmetry. So it's a nice odd function. And an odd function, your f of negative x is going to equal negative f of x. When you think about your cosine function, it went like this. It had that y-axis symmetry. It's an even function. Sorry about being so crooked. Even function, f of negative x equals f of x. Our tangent, you're dealing with another odd function. F of negative x equals negative f of x. So that goes right in line with the fact that sine and tangent are odd while cosine's even. So we learned that already, but just a different way of showing it or verifying it. Okay, so you got all these identities so far. Know these inside out, be able to use them. We're going to learn a ton more, but this is going to be the foundation of the identities. All right, so then with these identities, we're not going to be verifying identities just yet, but we're going to be using these to do some problems. Let's start out here. Let's say you have that the cosine of theta equals 5/8, and you know that theta is in quadrant 4. Okay, so quadrant 4 is over here. A smart trig class. Here cosine's positive, so would be secant, but the others are negative. So that's good to know. Alright, so with that fact, and we know what cosine theta is, let's find sine theta. Well, one of our identities, the Pythagorean identities, is that sine squared theta plus cosine squared theta equals 1. So we can do a little plugging in. Sine squared theta plus 5/8 squared equals 1. Sine squared theta plus 25/64 equals 1. So sine squared theta equals 39/64. Like by the time you subtract, you take this 64/64 minus 25/64. So sine theta, we got to do a square root of 39/64, but which square root do we do? Positive or negative? Well, in quadrant 4, cosine and secant are positive. Everything else is negative. So in this case, we need the negative. So we get negative square root of 39/8. Square root of 64 is 8. Then what if we're asked like for tangent theta? We can use our identities again. Tan theta is sine over cosine. So in this case, tan theta is negative square root of 39/8 over 5/8. So that's negative square root of 39/5. There's that. And then secant theta secant of negative theta, let's say they ask for that. If they ask for secant of negative theta, well, we know that that's the same thing as secant theta, which is 1 over cosine theta. So that's 1 over 5/8, which gives you 8/5. So you can go through and you can use these identities to find all these values without ever having to draw triangles. Like if you have a starting value and you know what quadrant you're dealing with, your identities can help you to find some of the other trig values. So you're going to be doing some practice with that. Okay, then you're also going to be taking identities and using them to write trig functions in terms of others. Okay, let's say you're asked something like write the tangent and theta in terms of cosine theta. So identities can help you to transform things into other forms. So write tan theta in terms of cosine theta. It's all about completing the puzzle and doing things in other forms. All right, going back up here to our identities. We have one where tan theta equals sine theta over cosine theta. But that's going to leave us with sine in there, and we're supposed to strictly go to cosine. We have one where tangent squared plus 1 equals secant squared. Ooh, secant squared is 1 over cosine squared after all. There we go. Let's use that one. Tangent squared theta plus 1 equals secant squared theta. Tangent squared theta plus 1 equals 1 over cosine squared theta. Tangent squared theta equals the 1 over cosine squared theta minus 1, which equals 1 minus cosine squared theta over cosine squared theta. Let's do the square roots of both sides. Tan theta equals, you gotta do positive negative square root of 1 minus cosine squared theta over cosine squared theta. Well, guess what? You can turn that into tan theta equals plus or minus square root of 1 minus cosine squared theta all over cosine theta. Because the square root of cosine squared theta would be cosine theta. So there you've got your tan theta rewritten in terms of completely in terms of cosines using identities. Cool, huh? Let's see. Let's do one more like that. Let's take 1 plus tangent squared theta over 1 minus secant squared theta. And let's write that in terms of sine and cosine. So first, write in terms of sine and cosine. And then there's another piece to the directions we'll get to in a little bit. In terms of sine theta and cosine theta. Well, we know tangent is sine over cosine, so we can rewrite that as 1 plus sine squared theta over cosine squared theta. And then we know secant is 1 over cosine, so we can do 1 minus 1 over cosine squared theta. Alright, clean up the fraction a little bit. Up top you're going to have cosine squared theta plus sine squared theta all over cosine squared theta. And then that whole thing you're going to have cosine squared theta minus 1 all over cosine squared theta. Shoot. Okay. You can do a little simplifying. Cosine squared plus sine squared is 1. You got 1 over cosine, well, and the cosine squares are going to cancel out, so you're going to have 1 over cosine squared theta minus 1. Let's reduce that. So that's completely in terms of sine and cosine. There ends up being no sine left, but you have the cosine. Now if they ask you to go a little further and now simplify so no quotients remain, now it doesn't these directions aren't saying you have to leave it with sine and cosine. If they ask you to go that much further now, like a second step, here you've got this on the bottom is the same thing as -1 times 1 minus cosine squared theta. So what you essentially have is negative 1 over sine squared theta, right? And then that's negative cosecant squared theta. Pretty cool, huh? You can keep simplifying things down, just still in terms of sines and cosines here. And then once you get it down to here, and there's no quotients remain, you rewrite it as negative cosecant squared theta. So you're going to have lots of fun manipulating and changing and transforming. It's like this big puzzle you're trying to solve, and then you're trying to get things down to certain terms. So have fun with that, and I look forward to seeing you again soon to do more identities.